Here we go, another episode in the construction of our crazy project, where we decided to combine an old Volga 21 with a new Bugatti Chiron. Yes, this story has dragged on for quite a while, and over the past 2 years we've redone everything a couple of times. But today we can confidently say that we are on the home stretch. Enjoy watching. In the previous episode we finally finished making and carefully installing all of the main body parts, put them onto the car itself, and showed you the final rough look of the project. Overall, that's how it's going to stay. The proportions and shape won't change anymore, but that's only half the battle. Now all that's left is to fit and install everything perfectly. To do this, we'll have to come up with, make and install a large number of parts that at first glance no one will even notice. But if we don't make them, the car will look odd and incomplete. Most often, this is exactly what separates a good project or tuning job from a bad one. Attention to detail. As the saying goes, the devil is in the details. That's exactly what we'll be working on today.
Now it's the door's turn. When we put the shell on, our doors suddenly stopped opening as they should have. We spent quite a long time really trying to figure out exactly what the catch was and where the problem actually lay. And then we realized that the shell was actually blocking the door. So it turns out we need to cut the door along this curve of our plastic overlay. That's what we're gonna do now.
After we mark the line along which we'll cut the door, in essence, that's the threshold line. We remove it, lay it out on the surgeon's table, and prepare it for the operation. To do this, we take out all the inner parts, so we don't accidentally cut off anything extra. 5 minutes later, we removed all the wiring and the window regulator, fixed the cutting line precisely once more, and strangely enough, started cutting.
I am free like a bird in the woods. I am free.
The difficulty is that these doors are made of aluminum, and if it were made of steel instead, I think it would be much easier for us to work with and handle. We'd cut it carefully, shape the bottom exactly the way we need, and then weld it back together. We haven't learned how to weld aluminum yet. Yes, we could have asked other specialists to help us with this, but after thinking it over, we made the decision to handle everything ourselves, relying on our own abilities. So we'll proceed with this type of repair. So we cut off this side, cut off the inner side, and we'll make the entire bottom part out of composite material and glue these two panels together, the outer and inner door skins. Now, about the door opening. Here, our fiberglass panel fits quite well with the original BMW sill. Basically here, we'll very carefully fill in this gap, roll it out thoroughly, and then extend and continue the sill all the way up to this point. And here as well, we'll also make a fiberglass panel. So we'll keep the original BMW door opening as it is, metal, without welding or cutting anything. And here we'll make a fiberglass panel of the shape we need, which will ensure the door fits tightly against the opening. We're fixing everything with fiberglass because we bought a lot of resin and fiberglass mat, and we have nowhere else to use it. We'll be working with it.
Now, let's move on to the most interesting part, the technique that I think most of you have never seen before. To be honest, I myself just learned about it for the first time now. But it's actually super reliable, relatively simple and inexpensive. It'll last 100 years, I guarantee it. That's exactly what Andrei said.
Soft music is playing gently in the background.
The technology for gluing the aluminum door will look like this. Along the entire perimeter of the parts to be glued, we carefully drilled a series of small, evenly spaced holes, through which, using an old and somewhat forgotten macrame technique, we patiently and skillfully threaded a roving cord. We then unraveled the roving fiberglass and made a strong, durable cord out of it. We stitched around the entire perimeter with these kinds of stitches in both directions, and in some places we literally sewed the aluminum parts together. After that, everything is saturated with polyester resin and covered with fiberglass mat. As a result, the resin seeps into our holes, saturates the cord from both sides, and the metal ends up not only glued, but also quite literally sewn together. It's quite an interesting and fairly reliable technique.
But seriously, this is actually a working method. It's called a composite rivet. The door itself is made of aluminum. We also used aluminum to build up the main frame, fixed the panel with rivets, and then reinforced everything with fiberglass cloth, covering the repaired area on both sides with it. As a result, we have an aluminum body that is reinforced with composite material on both sides. In the previous episode, we decided to slightly extend the front fender, which means now we need to lengthen the side skirt as well. That's what we're working on now. First, we remove the side skirts from the body. It's all very straightforward here, since the shape of the side skirt is simple. We cut it and added the missing piece. then another fitting, adjustment and so on, over and over again. After half a day, the door fits perfectly in its place, opens without any issues, and the gap with the seal looks factory made. Now, the same result needs to be achieved with the door opening. Here, the usual fiberglass mat, resin and long hours of adjustments come into play. After managing to create a smooth transition between the two seals, we work on the opening, to which the sealing rubber should fit snugly. Let me remind you that at the core, we have an original BMW door, fully in place, on its native hinges, in its original opening. This means we will keep the original lock, window regulator and sealing rubber. But as you remember, we trimmed the bottom of the door. Accordingly, the lower part of the opening also needs to be modified. As a result, we welded metal plates that fit perfectly to the shape of the new door. The main challenge here was to make the junction of our seal with the BMW body as seamless as possible, resembling a factory finish, while also ensuring that the seal remains a removable element. To achieve this, we used metal tape to create a separating layer. Then we had to remove the custom-made cover, fit it, finish the surface, figure out the method of attachment, and solve a bunch of other issues that come up during the process. In the end, to implement this solution, we had to redo everything several times, and the whole process took about a week of work. But in the video it only takes a couple of minutes. And it's pretty much the same with every single part. We trimmed the door, fitted it to our new door opening, made the minimal gap, and now we are going to install the Volga handle in our door, supposedly from a Volga. But there are a lot of nuances that come up. It has this kind of curve, and it was positioned very high up. We don't like that placement. It doesn't look harmonious. We're going to install the handle in the old spot where the BMW handle used to be. Our Volga handle needs some modifications. First of all, it uses a different opening mechanism. Here, you press the lever, but in the BMW, there's a cable that gets pulled. We solved this issue by modifying the Volga handle. This is a trial version, and this is how it looks. We filed down the ends of the handles at the contact points to change the angle, but even that wasn't enough to get the handle into the position we wanted. So we made these plates, which will be glued in here, using the method we already know. And here we've set the handle at the desired angle. Here's how our mechanism works. Now it opens with the push of a button. And here are the platforms that will set the handles at the angle we need. And here, using the familiar method, we'll roll in and glue these plastic plugs, joining them with the door itself. If we go back a bit, we can see how those very spaces were made, the ones that set the handles in the desired position. Here everything is just as straightforward. First, we generously covered the mounting areas with tape, then filled them with fiberglass, and after it dried, we had spaces that fit perfectly to the handle mounting points. We refined the shape after installing all of this directly onto the door. That's exactly what we did. First, we placed the blanks in their positions and thoroughly rolled fiberglass onto both sides of the aluminum door. Next, we prepared the door for priming. Just a little more patience. And at the very end of this episode, we'll show you how it all looks in the end. In the final stage, we remove all imperfections using putty, and the base is ready. First of all, we thoroughly sand the surface to bring the door to perfection. The next step is to degrease and finish the surfaces with putty, not forgetting about the reverse side. Well, and then long and hours of fine-tuning are needed so that after the final painting there are no sags and the door doesn't reflect light unevenly. It's really not easy and not quick. Without proper experience, it's hard to do. Fortunately, Andrei has been doing this his whole life, and in the end, the surface is brought to perfection. At least, that's what he assures us. Fortunately, the end of the project is already in sight, and we'll be able to see for ourselves. The next element that needs attention is the base on which the front bumper is mounted. Originally, is this kind of stamped steel part. It's almost impossible to find one in decent condition, but even if we managed to buy one, we would still have to modify it to fit our dimensions, which are different from the original. That's why we decided to make an alternative ourselves. In the previous episode, we symbolically put the bumper in place to show you the overall picture. At that time, the mounting platform didn't look presentable, so now we'll work on improving it.
About the bumper mounting, I came up with a bracket that bolts onto the frame rails. We trimmed the frame rail so that the radiator grille would fit. It's bolted on from underneath. Then it runs along the bumper like this, following its shape, and the bumper itself is attached with these two bolts here. I blatantly welded on these gussets because originally the mounting was only on these plates. They were kind of crosswise, and these edges too, and they flexed a lot, wobbled, they had no rigidity. I checked how it's done in the original, and the mounting is pretty much the same there. So here there's a bracket that secures it. This tab is so it doesn't wobble around here. That's the setup. And on top, all of this is covered by a fiberglass trim piece. And to relieve it a bit, I decided to glue it in here. This kind of gusset, a rib that follows the shape of the bumper. And this plate is fastened from below with two bolts here. And it also holds the fenders so they don't wobble.
There's nothing complicated here either. And it only took Andre 2 or 3 days. We place an element that follows the shape of the bumper onto the fiberglass plate. We cut it out of particle board, but that doesn't really matter since this piece is completely wrapped in fiberglass on all sides and is only needed to give it the required shape. In the end, when the element is ready, we prime it together with the prepared doors. Finally, we move on to the most interesting part. This is what we've gathered here for today. Specifically, the creation and installation of a mechanism with a retractable gear, so to speak our response to Rolls-Royce. But in order to integrate this mechanism into the hood, first we need a proper hood.
Initially, the plan was to keep the aluminum BMW hood frame and glue a plastic shell from the Volga onto it. But then I thought, how would we bond aluminum with fiberglass? Plus, it's not in the best condition, it's torn here. So we'll make it out of fiberglass as well. That will be more reliable and simpler. And we'll put a bit of filler on all these spots and cover them with aluminum tape. And we'll roll out this amplifier's internal component. Let's get started.
So the main idea here is to keep the key elements of the reinforcement original. That is, the mounting points, hinges and lock fixtures. This will make things much easier down the line, and the car will have a near factory level of reliable construction, if you can put it that way. To achieve this, we decided to make a mold of the original reinforcement, and only then connect it to the hood overlay from the Volga.
Previously, a plastic hood reinforcement from a BMW was made, and in theory, a plastic shell from a Volga was supposed to fit onto it, but the width of our hood is a bit like this.
Yes, the BMW hood is significantly wider, so we'll have to make a new reinforcement, based on the main mounting points. In other words, for the hood to function like the original, we need to relocate the mounting points for the hinges and the latch locks. That's what we're doing now, removing all the unnecessary parts with an angle grinder. At this point it became clear that the hinges don't fit our dimensions at all, so we'll have to move them a bit, meaning place them a little closer together. It's all very straightforward here. We unscrewed, measured, marked, then drilled, enlarged the holes, tacked on nuts to create threads, and after half a day of Andrei's work, we have widened, sturdy mounting plates where the hinges are securely fixed. After that, we attach the hinges to the fiberglass reinforcement, test fit them, and then move on to the hood.
On the car, I tacked on this lower reinforcement, which was left over from the BMW. I shortened it and adjusted the hinge areas. The hinges were positioned on a different plane, meaning at a different angle, and the BMW hood is much wider. That's why there's a joint here between these two reinforcements. It's glued on with bonding paste. I tacked it right onto the car, positioned the reinforcement and applied the paste. Then I secured the plastic shell of the reinforcement with self-tapping screws. The same situation applies to the front part. This part here remained original from the BMW and it doesn't really line up well here. I cleaned this area and here it will be reinforced with fiberglass mat. We won't have a cross brace for the reinforcement. There will only be 2 strips along the edges. This is a special type of foam that isn't dissolved by polyester resin. With its help, we create these 2 reinforcements and the whole thing is covered with fiberglass mat.
After Andrei laid out the plan for the next steps, he immediately set about putting it into action himself. Gold, not the master. As a result, we'll end up with a strong lightweight fiberglass hood that's practically eternal. At the very least, it definitely won't rot or rust. So, we have the hood ready. Now there's just one small thing left to do. We need to come up with, design and build the mechanism that will extend and retract the deer figurine. In the end, it should look like this. First of all, we need to assemble a prototype to test it out and identify any weak point. We'll make the prototype from whatever materials we have on hand that we can work with in our workshop. And once we have a working model, we'll order the parts to be cut from the proper suitable materials. Sasha Makarsky was a huge help to us in developing this mechanism. In fact, that's him you see on the screen. Not many people know this, but he has participated in many of our projects, though he always stayed behind the scenes. After looking into it, it became clear that similar mechanisms for the Volga had been made before us. But for me personally, the shape and size of the hatch, which is located on the hood right in the most visible spot, plays a very important role. And the main task here was the following. The hatch had to be as small as possible, just big enough for the deer to pass through in a vertical position, and with almost no visible gap at all between the hatch and the animal. To make this idea work, it became clear that the deer needed to be inside the mechanism and come out in a vertical position, only switching to horizontal afterward. Accordingly, the mechanism cannot be smaller than the deer itself, but in my opinion this is very important and fundamental. I really didn't want to ruin the appearance with a huge, oddly shaped hatch. Yes, in the end, the mechanism turned out to be bulky. But what does it matter if it's hidden in the engine compartment, where no one can see it? But an ugly, huge hatch is visible to everyone and ruins the look every day. That's the logic we followed. At this point, we've solved almost all the main technical challenges. The only unresolved issue is the wheel rims. There simply aren't any ready-made solutions that meet our requirements. And that's not surprising, since only a handful of people work on projects like this. But everyone does maintenance on their own car. After Sanya assembled the prototype, we gave it to Andriukha. First, we cut out the hatch. At this stage, it was done roughly and with extra margin. The next step is to securely fix the mechanism onto the platform under the hood. Right now, it's been made as a rough draft and with extra material, out of fiberglass. When we install the final, modified mechanism, we'll also refine it and put it in order. But for now, we need to achieve precise alignment and gaps.
So, since we are working together now, I'm working on the bracket to install this whole assembly under the hood. Let me remind you that for now, we still have a plywood prototype of the entire mechanism. It needs to be somehow fixed and secured under the hood, and the hatch where the deer will pop out needs to be precisely aligned. For now, everything is just held in place with some wooden planks. Obviously, the hatch needs to be moved a bit closer to the windshield. We missed the mark, but that's how it is. And there will be a lot of work ahead to install it so that the deer comes out flush with the hood. For now, it's still sitting too deep in there, so we'll need to play around with that.
Make the turnout visually stronger so it really stands up.
In the end, the first version of the hatch didn't work for us. We covered it with fiberglass mat, and in the same spot we are cutting out a new one, after which we refine the shape. The next step is to carefully make a plug that will perfectly match the exact shape of the hatch. To do this, we tape the backside, apply a release agent, and once again cover this niche with fiberglass mat. But this time the fiberglass mat won't stick to the hood since we've applied the release agent.
We're going through this summer together, each and every one of us.
As a result, after just a few hours, the resin actually became fully dry, and we have this kind of blank, which fits the shape perfectly.
We keep wrestling with our rather complex and intricate cuckoo clock mechanism, specifically the part where the little cuckoo bird pops out to announce the time. So we decided to make two of these carefully crafted hatches, which will gently and securely cover our hood opening, leaving a small deliberate gap like this. There are two hatches, because one of them will simply be an empty hatch that always stays closed, and the other one will have our deer carefully mounted on it. The challenge is that these hatches are positioned very close to each other. We designed the mechanism so that it would take up as little space as possible, which is why everything is packed in so tightly here. But it seems that on the second try, I managed to make the shape of the hatch in such a way that they don't interfere with each other. And now we're carefully working on positioning them. We'll also have to move the deer from its original position to here, because this backdrop seems to hit the hood when it's closed. But we'll only find out for sure once we actually mount the deer. And let me remind you that our mechanism is still a prototype. It's still made of plywood and pretty rough, so it doesn't work perfectly, yet it's a bit jerky and twitchy.
To the second one.
That's how it's supposed to look. One hatch is empty and the other hatch pops out with the deer, and the hatches will be flush with the hood. So that's how it closes. It should be flush. That is, there's still no final fitting yet. Everything is still rough.
After that, we spent a week fitting, refining and reworking. Yes, we had to modify the mechanism a bit. It was a matter of a couple millimeters, but otherwise we couldn't achieve the intended result.
For a week until the second, I'll go to Camarobo on the Sunday commuter train to you, to the edge of the earth. Divers are searching for treasure, but I don't need any treasures. I just want ships not to sink in the blue sea. To eat to Camarobo, and we are going to Camarobo. I just want in the blue sea.
Oh, it fits, listen, not bad. Not bad at all. Pretty good, actually. Yeah, it works just fine. Everything's great.
In our project, we decided to implement a protection function. When you touch the deer, a touch sensor is triggered, which signals for it to hide and close the hatch. Our favorite classic touch button. The mechanism is also equipped with reliable limit switches for both the minimum and maximum positions, which will automatically turn off the mechanism in time.
As a result, it will look like this. The deer reacts to touch and immediately hides. By that time, the liquid putty had dried, and we are doing the final smoothing of the surfaces before painting, or rather, even before priming. And on top of the primer, we decided to apply a rough layer of red paint. Of course, this isn't the final paint job. This is done just to see an alternative color solution, and in this episode, we decided to try out this option. I think there will be comments saying that this is a waste of time and money. Partly, yes. But compared to the effort and investment put into this project, it's just a drop in the ocean. Besides, in any case, we're applying primer to these panels, which means the car has to be masked off anyway. In the end, the costs amount to just half a liter of paint and 30 minutes of Andrei's time. But in the end, we get to see how it looks in real life and make a decision for the final paint job. And of course, the series becomes more interesting. All for you.
Had the best day yesterday. We didn't go out at night though until morning, but now it's time to hit the road. For us too. The very best day was yesterday. We didn't go out at night though.
When we installed the headlights last time, there was one little thing we didn't like. Is that the headlight is mounted through this kind of pot. It's needed for adjusting and correcting the direction of the light, but the headlight sticks out a lot compared to this chrome ring. It really sticks out, meaning it's not recessed down. So we really didn't like that aspect, so during today's assembly we won't be installing this pot. Later we'll come up with some kind of solution to this issue so that the light adjustment remains and the headlights can still be adjusted, but for now we'll just boldly attach them directly to the fender so they don't stick out as much as before. That's how it was, and we really didn't like it. So we're just going to attach them firmly to the fender like this. obviously this isn't the right way and it's only temporary. We've also ordered these new chrome strips that are mounted here along the top of the fender. We haven't fully decided yet whether we'll keep them here or not, but we'll at least try them on for fitting. Although at first glance they seem to be of perfect quality, if you look closely they reflect a lot of glare and are actually quite crooked. And again, if we're gonna install them, maybe we should use different ones. But where can we get others? If even getting these was a big problem. All right, for now we'll just attach them here and not pay attention to their quality. At this point, we've adjusted the mechanism and set all clearances. Soon, we'll replace the plywood base with a metal one we've ordered from a machinist, then lubricate the guides for smooth operation. It's hard to do this with plywood and we don't want to waste time on it. But overall, the operating principle is clear. Many of you may wonder, how much do these toys actually cost? As is our tradition, after each episode we post in our Telegram channel with all the numbers, challenges and details that didn't make it in. A post with the cost of developing the mechanism is already in our Telegram channel. The link is in the description. Thank you for watching and may you have good fortune from the X. The Commission of the Federation of Federations. Once again, authoritatively. Subtitles by Dimator Zok. It's 3M touchdown call buzz down.